So I've been through 4 decades of new technologies. When I started work as a young engineer, it was networks, and to know networks is like you are great, and then it went on to the .com, and to be in the .com, I got excited because that's where things would start changing. It's going to change our lives. That was in the 90s, and then in 2000, in the first part of the last decade, it was more on mobile technology, and I went into the ISP space, as a mobile service provider. And just when I retired late last decade, I couldn't sit still. And the irony is that I actually started looking deeply into blockchain technology in Australia, in Cherrybrook, here, Sydney. So that was when I actually looked at it so seriously and spent, something like 2 years in there, hiding in my room, trying to understand the technology and making real utility of it. So that is where it all started 6 years ago. One of the things was that late 2013, that was when, sometime in June 2013, that was when the smart contract, the concept of smart contract came about, right? But it was very primitive, and it was so primitive that there are lots of things that I wish were there, but it wasn't there, right? So what happened was when smart contract came out, I thought this is where it's going to change the direction a bit. But after having spent 6 months in Ethereum, I realized that is a great experiment, more so than a great technology for us to make use of and apply in real world use cases. So, and until today, it still remains, in my personal opinion, that Ethereum and its smart contract, a great technology, a great invention, but it remains an experiment in as far as I'm concerned. I have differing views about it. And then that's when I stumbled onto NEM, right? Because that was when the developers started to listen to me and do things that I think is more applicable to mainstream industries.
So what in particular was that? Because I think there are some people who might agree with you, or some others who might disagree with you on the status of Ethereum. So what in particular about NEM do you think separates it, and what drew you to it? And so obviously you created it because you wanted something different.
Yeah. I think the first thing is that you cannot have an immutable contract, because if even you just look at one of the most popular software in this world, like Microsoft, right? Microsoft, you have bugs, you have releases of fixes and patches and whatnot every so often, right? This is a multi-billion-dollar company with thousands of engineers and software developers, and yet they have bugs. How can a business rely on a few great programmers, right, programming the smart contract and putting it onto the blockchain and seeing it fail because it's immutable, and therefore killing your business, which could be a multi-billion-dollar business like a bank, right? So it doesn't make sense.
Not at all. That's a bit scary, actually. I don't think you want your bank going offline.
No one would do it, right? No one in their sanest mind would do it, right? But then the thing is, what we have done then at NEM is that, look, get that out of the equation, forget about smart contract. If there's ever going to be a smart contract to calculate your interest, for example, leave it out there as it is, what the banks are doing today, right? Not on the blockchain and making it immutable. And if there's change, you can change it. If there's an error, you watch it drain away from you, right? So things like escrow, on-chain escrow, they call it. If Hannah and I decide to transact, I don't trust her, she doesn't trust me, and usually what we'll do is we'll appoint our own lawyers to be our basically escrow, right?
To hold the money until we've actually we're happy that the circumstances on which that money should transfer have actually occurred. So sort of like settlement of a house.
That's right. Yeah. So now if I decide that I want to transact with Hannah without a lawyer, it's easy. So I owe you 5, you owe me 5 of something else, right? And then we say, I pull the 5 from you, from your account, I just pull it from you, I sign, and then if you agree, you just sign, it gets exchanged. And that is the simplest smart contract that is good for maybe 60 to 70% of the time, right? So why do you need to rewrite smart contract and worry about bugs and leave it to the hands of a few good programmers who may make a mistake as well, right?
So effectively it was a matter of going, what is the simplest way to give people what they need? So you mentioned sort of banks there. What is the idea then that so the idea behind creating them was obviously to kind of create another layer on top. So to say, let's look at Ethereum as the experiment. Let's create something that potentially works for banks.
That's right. And what is most important elements? What are the most important elements? Are the ability for us to create multiple assets of different kinds. For example, in the blockchain, in the Bitcoin blockchain, we have the colored coin, of course, but it was a convoluted way of doing a colored coin. A colored coin is basically another asset sort of thing, right? So you color the same coin in different colors to denominate different types of assets, and you give it a different name so that one asset can mean Bitcoin itself, then the other asset could be gold to represent gold, right? But in our case, in NEM, what we did was, okay, so you have the need to develop multiple assets. Therefore, we'll make it so simple, as opposed to what the great experiment, the Ethereum. Sorry, some of you are possibly Ethereum, and Ethereum has a big conference here. But anyway, the fact of the matter is that they needed to create a smart contract to represent an asset, whereas we pre-create the asset in our own blockchain, so that you are then, as a user, you do not need a programmer to do it for you. You just do a few clicks, you create a new asset. So that was how simple it was to create a new asset. And
so it was almost plug and play.
Yeah, it is, in fact. And then there's another very important element in the financial space, is that the ability for us to approve or disapprove a transaction. So if I'm the bank and you are the customer and you needed to transfer money to Sue, then what can happen is this: you will transfer and you sign off a transfer or sign off a transaction. But as the bank, I must be able to approve your transaction, because you could be a suspect for money laundering, right? Yep. And therefore, I can stop you from, even though you have signed to make a transaction to Sue, you still need my approval, right? So I've put in an element of real-world use cases in the NEM solution. It's not just but we all decided as NEM, right? And that's where I said the developers, the guys in there, listen to me and understand from my perspective how we should take things to the real world.
So it was basically a matter of saying, we're creating something and we want it to be natively within its innate fundamental software layer to do these various things and to do them for the real world. When you say you're doing it as a group, expand on that a little bit, because there's a lot of talk about communities in the blockchain world.
Well, basically the core team, right? There were the programmers and myself, always more like front-facing, the community and things like that. So I'm like in between, being a lot older than they are. Some of them are old enough, young enough to be my children. So, but yeah, the experience, it's whether it's a good experience, bad experience, whatever the case may be, but it's my 2 cents. Yeah. So it's just my 2 cents, right, to them, and they listen. So if they listen and then they start doing and working on it, that's where I see a beautiful product or a solution that's being invented or developed by this developers of NEM.
But you've done something slightly different more recently, because you were the president and were the co-founder, but are now working with ProximaX. Yep. So that is linked to NEM or uses the NEM software?
Yeah, it does. So what happens was, as the journey went on, right? I spent about a good 2 years trying to sell this solution to the bankers. And the problem with the banks is this, or the financial industry for that matter. The problem with them is that they're huge, number one. Number two, because it's a hierarchy of, it's a bureaucracy where, they have budget, yes, of course, but they want to do proof of concept and not making a decision. Time moves on, it's already 2 years, right? So it's hard to sell that's a blockchain solution to the financial industry. And that's where I started moving on to something else, which is ProximaX.
Yeah, it's interesting. A lot of the time you'll go and you'll speak to a large institution, you'll say, we're using blockchain. They go, yeah, that's really cool. And then as you say, you go through the proof of concept, you go through the ideation, all these processes, the workshops, and then you don't actually get anywhere. So how have you broken that impasse?
Okay, this is a very good question. Sometime early last year, I decided to say, okay, you bankers, you don't want to do anything about it, no worries. I'm going to apply for license and do it myself. So, which I did actually.
Congratulations, that's not an easy process.
No, it wasn't easy, but it took 1 year. We just got the license to do mobile payment in Cambodia in February. And so now it's 2 months into the license, and we are rolling it out very soon, like next month sort of thing. And we are finishing a lot of the things using entirely blockchain powered. And that's where the beauty is. It is so inexpensive to roll it out.
So when you say blockchain powered, what do you mean by that?
There are two types of, obviously there are two types of approach to this. The traditional that we all know is to develop the solution. You engage a group of developers, or you have in-house a group of developers who will develop your solution based on maybe Java platform and a database solution, and then you start working on it and designing it, and then you're basically designing the ledger, right? Underneath it, that is used to power the mobile payment system, right? And to do that, you need to worry about the security, you need to worry about the data center, the cloud, whatever, the entire network software stack that you have to put on, and the developers working on it. Whereas in the case of the blockchain technology, everything has been written in there as a ledger solution. Now, all you need to do is to develop the application. And what I mean by the application is the business rules, as well as the user interface, as well as the user experience in making the product or the application usable. Whereas you don't now need to worry about the back end, because the blockchain technology is there to ensure the security of the system and integrity of the system, as well as availability of the system. So you have taken out a lot of the pain in developing a world-class solution.
So effectively you're using this as, let's say, the engine for the system, or the internet for the web page that's being built on top. And then you're making it easier for people to build what they want. So you're doing mobile payments in Cambodia. What are some of the other use cases you've been working on? Because I know you've done some stuff in the UAE, in Japan.
Yeah, that's right, yeah. So basically now with this ProximaX, this is basically ProximaX. We have moved on from them. And what we have done, maybe I give a little bit of an introduction to what we're now doing with ProximaX. As I explained earlier, the NAM is a great engine, but if you don't have the wheels, as well as the body, as well as the steering wheel and the dashboard, whatever, right? Then it remains an engine, which could be the world-class engine. So what we did is to add in more things around it. And a few of the elements, technologies that we have put in includes a file storage system, a database system, as well as including a streaming layer, which means you can actually live stream videos as well as chat on the on this platform, right? And what we have done now is to put them all together so that they remain a platform for us to now develop applications on top of it. So it has extended the use of one blockchain technology to include more technologies, distributed technologies put together, and allow us to develop applications. And applications include things like the mobile payment system that I was talking about. And part of the mobile payment system, you have the KYC. KYC means know your counterparty. And know your counterparty is becoming a very important element of the financial industry, where the regulators insist that you need to understand your counterparty that you're dealing with and allow you to store, to ensure that they're bona fide, right? And to do that, you basically now can store those information in the file storage system, right? So, and that's where the KYC is being used as an application. Now, moving on, you look to the sideways of the spectrum of applications. You could have things like national identity, right? Where you could actually store all the information. Well, Australia hasn't got a national identity, but a lot of countries have, right? So you can store the information of the person in the file storage as well as a database. So this is where we have one application, one vertical, and you extend beyond that, like the UAE, where we have implemented a voting system for the, well, MOCD is Ministry of Community Development. It's basically a welfare sort of thing, ministry where you help the poor or the challenged people, right? And that's where you could use they have used that our solution to include voting, right? Voting as in today we're going to do this program. How many of you like it? And then someone, a group of people will vote, and they go on with it, right? To carry out that program. And then they have also included something like a collaboration within their organization, where they could store files, and keep them within the organization and encrypted within the organization. But extending beyond that, now that they have already got the infrastructure in there, they can continue to develop many more applications on it, on the same infrastructure. And that's where the cost, the barrier to entry is low, and then you can do it incrementally in terms of the number of applications you can write on top of that platform.
So this platform is basically that underlying blockchain platform, which is the transfer of value, the storage of the files, then you've got the streaming of information, and so what you can then do is use aspects of those. I like the idea around the KYC process, because part of that, you actually need your identity. That's part of proving that a person is who they say they are. So if you've got the identity already through the system, and then you just say, well, I've got the identity, combine it with other information that you need, transfer it to, say, the organisation who's the regulator who potentially is involved, you've actually got the system all in the one place. So it makes things much easier. So there's a whole synergy there. Yes. Is that the whole idea behind this, is you're creating a system which actually brings everything into the one realm? That's right, yeah. Precisely the point. You just imagine how a local government decide to put in and roll out the infrastructure. The good thing about it is that the same infrastructure can be extended for the federal government, just from a local government, right? And everyone adds on and build a network. So it is something that is beyond our imagination, that at the end of the day, you have a homogeneous system that powers the country, right? And it doesn't fail. Right? What more can you ask? And it's inexpensive. So, and at the end of the day, it's all about starting to develop an application on top of this network, whether you're from the immigration department, or whether you're from the education department. You could actually cross-transfer information or allow information to be sent across, and you can silo your information so that the other ministry does not see what you have within your ministry, but all in the same network, sharing the same computer systems. All encrypted files are stored all over the place, sharded as well as encrypted, like
jigsaw puzzles, all over the place, encrypted as well. So this is something very, something that's so exciting, and that's why it's keeping my adrenaline pumping all the time,
Which is why it doesn't matter how old you are, there's always something new and something fun in this space.
Yeah.
So sharding is, of course, that process of the jigsaw puzzle where you say, this is my file, I'm going to store each of the thousands of pieces of the puzzle in all sorts of different places, but I can bring them back together when they're needed. But if anyone ever found one piece of the puzzle, they couldn't necessarily say, well, that's that particular person's identity. Is that correct?
That's right, yeah. It's encrypted as well, that piece, So you can, it's rubbish out there, right? But with the right, we call it a key to it, then you can actually extract all of them, put them together, and becomes something that's legible.
So you have mentioned this is inexpensive, but if you look at, say, the price of mining Bitcoin, that's hugely expensive and hugely taxing from an energy perspective. How does this actually overcome those issues? Or how have you managed these?
Well, I think a very important thing that we need to understand is that there are two types of networks, right? One is the public network and the other one is private network. I was basically referring to the private network because in a government, in an organization, in an enterprise, more than likely they do not want to share their network with anyone else because, there could be sabotage and whatever. But
so when you say private, you mean it's only available to those particular people who it's built for? That's
right, yeah. So within their network or accessible by anyone that they allow. It's permission network, basically, right? It's a better term, actually. Permission network, which means I own the network. But there are a lot of maximalists that say, look, you have taken away the distributed technology from this, and it doesn't represent distributed technology because it's owned by the organization.
So what do you say to them?
Well, I beg to differ because I'm not here to talk about distributed network per se. I'm not here to challenge them in the definition of a true distributed network. I'm here as an entrepreneur looking at applications where it is cost effective. So it is cost effective. So as what you were saying and commenting about Bitcoin being expensive to mine, right? So mining is an activity where in the public network, you require that because you need to incentivize actors who keep the entire ecosystem running, right? And these actors need to be paid for the time and resources that they put in, right? And this is where in the public network, you have mining activities, but in the permission network, you don't need to mine because all the nodes are owned by one miner, which is the owner, right? And they don't need to mine.
So you've effectively said, well, let's not look at this from the public perspective. Let's actually focus on the problem that we're trying to solve. Let's give the autonomy to that particular organization. Let's focus on that. So then how does it actually work in a decentralized manner? Because that is exactly the issue, is it not, when you speak to these maximalists, is they say, one person, surely that's not decentralized.
Yeah, they can locate and put their nodes and computers all over the place. One in Perth, one in Sydney, or 10 or 20 in Sydney, 5 in Perth, 25 in Melbourne or whatever, all over the country, right? So this is where the resilience and the power of the network is. So if I have enough, like say 20, 30 nodes, right? And because it's permission, so I have basically some sort of a fence around it, right? Where it is, in the first place, hard to access. In the second place, even if you can break through that fence, you can't access the data because they're all encrypted. And the fact of the matter is that if you have enough computers out there maintaining this whole thing, then it becomes robust, it becomes a very powerful network where it is self-sustaining. So there really is no issue on distributed per se.
So effectively what you're saying is you may be within the one organization, but that doesn't mean you've only got one computer.
That's right, yes.
Makes complete sense. So we've spoken about your work with payments, your work with welfare. So land titles, is that another use case you've been looking at?
No, I think I am actively looking at, still actively looking at the financial system. I'm still trying to break that big block there, but
It's a challenge and you've got to overcome it.
The challenge could be is to start doing it myself, right? And again, it is inexpensive. That's where to build a banking system, the core banking system, probably cost between $100 million to $500 million to $500 million to build a core banking system with all sorts of applications surrounding it. Applications include money laundering, AML, monitoring, KYC, services, whatever, right? So, but the core behind all this is basically a ledger. It is all that is to the core banking system. And they are maintaining that because they built it from maybe 40 years or 30 years ago, where it now becomes a legacy, and they keep on adding applications after applications over and on top of it. And that's where the cost is. And if it ain't broken, don't fix it, right? So they're not going to touch it, right? But here I am, if I start a new virtual banking system, all I need to do is start off with a blockchain, and then if I decide to sell gold as a service, right? Or allow you to open up a gold account, or platinum account, or whatever commodity that you want to open up, it is as easy as 5 minutes. So this is where the challenge is for traditional banking system. First thing they do is the marketing department say, hey, look, I'm going to do this, right? I'm going to introduce a new product. And then
everything starts with marketing, doesn't it?
And of course, because that's where the money is, right? And then they go out to the back room and say, hey, guys, tech boys, can you get this thing done for me? Oh, 6 months at least. And I'm going to test another 6 months, right? So that's 12 months. So what's going to happen here? These guys is going to wait for 12 months before they can roll out a new product. Now, this is where the good thing is about blockchain technology. The marketing department decides, well, we want to roll out a gold account where we allow people to transfer money into this account and at $1,300 an ounce sort of thing, right? So that you have gold account, get 5 ounce, 10 ounce, 20 ounce, whatever the case may be. Goes to the tech boy, say, can you do it? Yeah, of course. Go ask my administrator. She's not a tech. She will just click a few things and it's done. It's as simple as that, honestly. And that's how we are doing it, right?
So the whole system is basically you can take someone like me who's a non-coder lawyer whose expertise is words and not cryptography. That's and right. I could then create this?
Yeah, you could. That's how simple it is. And in fact, the tech boys, if you're smart enough to come up with a business process and say, okay, you do it yourself, marketing girls or boys, right? You don't hassle me anymore. I'm going for my holidays. That's exactly what it is. And the great thing about it is that system will run. Will run and run, because if you have enough nodes, enough diversity, enough resilience, you don't really need to do much other than making sure that there's enough disk space. That's the limit of it, is obviously the disk space, right? You start storing petabytes into the system, then you really need to look at it and make sure that there's always enough room for expansion.
So effectively it comes down to what is the system resiliency and what is the system capacity. So that comes back to hardware, doesn't it?
Yeah, of course it does, but it comes back to cheap hardware. Inexpensive again. I don't need to buy RAID 5 or whatever technology, a bank of hard disk space, or go to the cloud and rely on the cloud services to do things for you, right? So you can actually still rely on the cloud, but you can have a diversity of clouds. Like, for example, I can put a few servers in AWS, and then I can put a few servers in Microsoft, Azure, or Alibaba, whatever the case may be, right? And then you just you have diversity. You have the ability to recover information from any of these networks, and you don't really rely on them per se.
And then that, of course, contributes to that whole idea of the resiliency. And this is where we get into this concept of a distributed, decentralized network that can be used anywhere in the world at any time. So, are we going to see a ProximaX bank? Is that where we're going?
Well, I don't know. I mean, it's a dream, but it's still a journey. I don't know how long this journey is going to be, but it's a journey. But one of the other things that I'm looking at seriously, other than the financial industry, is we call it business process management. Business process management is basically a workflow. For example, if you want to apply for leave within your company, you have to go through certain process within your company, right? And I was talking to someone the other day about insurance, right? There is a business process, and that business process is you file a claim, and then it goes on to the guy who verifies whether what you're filing for claim is right or not. And then it goes on to the payment department, and then the payment department goes on and on and on until it gets finally paid to you or not, right? So that's a business process. That business process can be put onto the blockchain, and this is how the multi-signatory comes in, right? Multi-signatory in the traditional smart contract is you write it yourself, but in them it comes with it, right? And one of the greatest things that we in electrical engineering and computer science we call it digital logic. That was 40 years ago technology, right? And we call it AND/OR gates. It's the fundamental of computing, AND/OR. With those fundamentals, you can do a lot of logics in it. So we apply the digital technology, what did I say?
The logic?
Logic, that's right, yeah. I'm getting old. Digital logic, right? You apply digital logic into multi-signatory, and you create a tree of signing and approval. So say, if either Hannah or I decide to sign either, which means Hannah or Lon decide to sign on something, then Gemma and Justina will take on to the next stage and decide to sign, but both must sign before the final output becomes yes or no, right? Because if Gemma and Justina doesn't sign, it stops here. So that's the logic, that's the flow. And then you apply that to business process, and that's where the whole thing, we can see a lot of things can happen from there. So from insurance to banking to KYC approval to land transfer between two parties, all sorts of things can now be used. So it is actually taking on the solution into the next stage. And see, the word blockchain is disappearing, right? Out comes new things. And that's where the excitement again is, right?
So, but you're saying though that this would have a blockchain as the fundamental basis, wouldn't it?
That's right.
And the reason for that is because in order to have these multi-signatory arrangements operate in the way that you want to, that is required, isn't it?
Yeah, and as well as it's like this, we've got an engine, we don't need to build that anymore. We just use the engine and reuse because everything is in there, right? So security, distribution, resilience, whatever, right?
So now that we have this engine and it's working pretty well, where is it going to go? What do you see this developing into? What are the not just the use cases, but how is it going to change the way that we're operating?
Well, I think the bottom line is this: if any company, any organization, including government, can reduce the cost of ownership of solutions, right, computer system, they would change. So it doesn't matter how you look at it, So at the end of the day, this is a very interesting thing that happened to me. I went to the bank, right, the central bank, I said, I want to do a settlement system. And then the bank looked at me, who's your backers? Who's paying for you? I said, I'm paying for myself. They look at it, they look at me and in awe, this guy, he's going to finance his own payment settlement system when it takes us millions of dollars to develop, or hundreds of millions of dollars to develop a system like this.
Or even billions.
Yeah. And here I am just saying, I'm going to finance it, You must be joking. Too much grass, No, he probably thought I have lots of weed, just before coming. But the fact of the matter is that you don't need millions, right?
So how can you do this with a couple? So when you're doing it with a couple of $100,000, that's because you're using this underlying platform, this blockchain.
Yeah, the blockchain itself is like 60, 70% of the solution, right? So what else do you need? The applications on it.
And then you're just saying, we've got our engine, we're going to build on top of it, and there we go. So how are you finding, though? I mean, obviously you have people who kind of look at you like the bank and say, I think you've got rocks in your head. How are you finding actually moving into this new area? How are you managing to implement it in this very traditional world and actually allowing it to reach its full potential?
Well, I think the way I'm going to do it probably will be through underdeveloped countries where the infrastructure is broken, where there's a need for such things, and that's where we can actually implement such a solution. But if you use a developed country like Australia, is unlikely, almost unlikely to do it, right? But that's probably why I moved to Southeast Asia, so that I'm closer to all this country and start working on those places.
So is this going to be the next layer of infrastructure for Southeast Asia?
Well, I think the infrastructure is, like I say, is a spectrum of information, of applications that you can put on. So that will be, the start of it all.
So they're basically, like we've gone with phone technology and we've gone, let's forget about cellular, let's forget about even landlines, let's go straight to the mobile phone system that we have with 4G and 5G. Same thing here, let's leapfrog what we're doing.
That's exactly the thing, yeah. I mean, you just look at China, right? It didn't have copper lines. Everything is fiber now. It skipped one generation of technology. And now they are onto the mobile phones, right? Same thing with Cambodia. They hardly have anything, right? So they move from zero to mobile phone and mobile connectivity. And Myanmar is the same, right? Laos is the same.
And you're working in all those countries?
No, I mean, my eye is there, right?
Well, you're well positioned being in Malaysia.
Yeah, it's a few hours flight, couple of hours, literally.
So watch this space. Next time any of us travels to Southeast Asia, we may find that everything is running on ProximaX.
Oh, I really hope so, but it's a dream.
Well, I think that leaves us on that note. Lon, thank you so much. This has been a fabulous conversation. We've gone through your entire career, the evolution of the industry from NEM, blockchains, ProximaX to changing the world. So thank you. Please put your hands together. Thank you, Lon.